Hello? All right. Today, I will be talking about generating E2E test code with LLM. All right. The key isn't better prompts, but better structure. So we've been building an E2E testing pipeline for ride-hailing app at Numo. And then along the way, we discovered that the quality of AI-generated code depends almost entirely on what context you give it. It's not how clever you ask. So we will cover 4 topics. First, what actually goes wrong when LLM write test code, and then how to structure context to fix that. Third, how it works in practice, and finally, takeaway. So let's start with the problem. If you ever asked an LLM to write a test code, I think you've probably seen this code that looks right, but doesn't work at all. I will show you a real example and break down why it fails. So here's what happens when you prompt write a login test for our app. And then the LLM generates code that looks reasonable, but none of it works. So in this case, we have like one test functions over there, and then there are some operation code, test code. In this case, the selector username doesn't exist in your app. The button says login, but it's actually signed in the app. And the last line taps welcome text without waiting for it to load. So it's not there yet in the testing timeline. But this code compiles very well. It even reads well, but it fails immediately because every value is made up. And there's no also wait strategy for this. So this breaks down into 3 patterns that keep repeating. First, it's about made-up selectors. The LLM invents IDs that don't exist in the source code. Somehow, it's very confident, but like all of them are fiction. Second, I think mostly any generated code applies to this, but it's all wrong text. The LLM gets very close, but not exact. So in this case, login versus sign in, it's just one word off, but it means all the test fails. Third, there is no wait strategy. The LLM doesn't know that some operations take time, especially in CI. I think it should be fine in logout. But it writes code that runs very fast, so which is causing sometimes flaky tests. So how do we fix this? The instinct is to write better prompts, add more detail, be more specific. But that doesn't scale, because every new test needs a new, carefully written prompt. For me, the answer is structure the context the LLM receives. Give it files it can read, not instruction it has to interpret. Here's what we built. Instead of fighting the LLM with longer prompts, we created structured files that give it the right context. I will walk through each layer and show you what they look like. There are actually 3 layers, and each solves a different problem. So first one is IR, which is intermediate representation. This defines what to test. It's a readable version of the spec. And next one is scenarios and definitions. These define what exists. The step order, selectors, and timeouts. And templates define how to write. It's mostly for call patterns and also conventions. And that is pipeline we have. It's quite simple. So starting from a PRD or design, and create an IR, and then generate code. So each layer narrows down what the LLM can do. And there is less room for making things up by LLM. Here's what an IR looks like. It's the spec turned into the structured format. So in this case, we have name, preconditions, input fields. So instead of letting the LLM read a spec and interpret it freely, we pull out the key information. What is the feature, and what conditions needs to be true, and what input fields exist, and what types they are. This is the same information a developer would figure out manually anyway. So we just make it just clear and structured. Then the LLM reads the fact instead of interpreting everything based on spec. So next one is scenario. This defines the exact sequence of steps for our test. So in this case, we have name, parameters, variants, and also steps as well. So for example, this test would require specific steps to run perform logging, accept write requests, complete write journey, etc. So each step is named, and the order is fixed. The LLM doesn't decide the flow. This file flows it. And we also have variants here, because one scenario can define multiple test cases. So in this case, we have same test case for anonymous writer and also designated driver as well. So you can just write one test, but with many variants as well. So next one is definitions. So this one lists what actually in the code base. In this case, we have helper functions, timeout as well, and also accessibility identifiers. So function signatures that actually exist. So it's quite easy for LLM to generate function which looks like right naming, but sometimes signature will be different. So that's why we need to have signatures as well. And also timeout values that have been tested in CI. So everything works in local, but sometimes it takes more time in CI. And finally, accessibility identifiers that are actually in the source code. So this directly solves the made-up selector problem. And the LLM doesn't need to guess, like button logging in the previous example. It reads it from this file. So if the ID changes in the app, you can just update one file, and every generated test picks up the change. So templates show the patterns that LLM should follow. In this case, we have the testing functions as well, and also some coding conventions at the bottom. So on the top, here the test class structure, it's quite simple, clean, and also using named functions instead of raw UI actions. And also, we have rules at the bottom. So one thing it's written here is that always prefer accessibility identifier rather than raw text, raw label text or predicates. Or we also have different patterns for the wait strategy that always use wait for existence for UI waits, but instead use threps sleep for like back-end heavy some operations. And it's always documented here with the reason. So without templates, every generated test has a slightly different style. But with templates, they're very consistent. So now let's see how this comes together in practice, and then I will show the order AI follows. And then a side-by-side comparison of what it generates with and without structured context. Here is the order AI follows every time. First, read the scenarios for steps and check definitions for existing code. Follow templates for patterns, and compose into tests. This is a fixed chain. Given the same inputs, the LLM produces the same output. So it's very structured compositions in the flow. And this is the proof. Same prompt, like write a light completion test. And without the context, the LLM guesses everything, including like wrong ID, arbitrary sleep, and wrong text. 3 lines, but it all fails. But with structured context, every line traces back to the source. In this case, perform logging from scenarios, and pattern logging from the definitions, the timeout value from definitions, and then the sleep with the documented reasons from the templates. So nothing is made up here. Every value has a source. That's the key difference structure makes in this case. All right, so let me wrap up with the formula. 3 things to remember. And one thing I hope you will take away from this talk. Here is the formula. Reliable AI-generated test code equals IR plus scenarios plus definitions plus templates. So each covers a different concern. What to test, what steps, what exists, and how to write. Together, they fill in all the gaps where the LLM otherwise guess. So three things to remember. First, structure beats prompt. Well, this is, in my opinion, but don't spend too much time crafting the perfect prompts. Instead, spend time organizing your selectors, definitions, and patterns into those files that LLM can read. Second, single source of truth. When everything lives in one place, you just need to update once, and then all the tests benefit with them. So both humans and AI can read the same source. So there's no drift, and also no inconsistency. Third, so context prevents guessing. When the LLM knows what to test, and also what exists and how to write, there's nothing left to make up. So guessing only happens in the gaps. Structured context fills these gaps. There's always one more thing in iOS stuff. So I think this is what I really want you to take away from my slide. So do not build for AI. Build for your team. Because the context that helps your team write consistent code is actually the same context AI needs. So I'm going to explain what it means. So when you structure your specs, scenarios, definitions very well, first, it is reviewable. And I think this is very important, because you can review the context before any code is generated. The IO files, scenarios, definitions, templates, everything, they're just files. So your team can review them, suggest any changes, and agree on them. So by the time the LLM generates code, all of important decisions have already been reviewed by your team. So you're not reviewing AI outputs. You're reviewing the input that shaped it. The second one is it's all single source of truth. So you just need to update one file, and then all the tests stay consistent. And this is also, I think, helpful for onboarding as well, because new member can read structured files instead of all the detailed test code. So my point is, none of this was built for only AI. This was built for team. And AI just happened to thrive on this same structure. All right, so I think that's it for my talk. So if you have any questions, please feel free to ask me. Thank you.